I'm up. Yeah. Oh, yeah. You can applaud me. Yes. So I was making these slides over the last few days, and it became reasonably apparent as I was looking back over my abstract of like when we submitted this, X months ago, that I was clearly going through a phase of just being like really angry at data transfer agreements and like, why is this so freaking difficult all the time? So that's, I think, where the title came from. I sort of suspect that actually, having come out of 3 days of a brain hack and meeting wonderful people and feeling really inspired about everything. Sorry. Yeah, I'm shorter than Cameron. What's up with that? Feeling really inspired about everything. I actually probably would have done like maybe a slightly different title for this. But the point of my slides is to help you access the complementary data and potentially access the data that is not totally open. The CC BY up in the top corner means that the slides are available online. You're welcome to reuse them, remix them. Just say that you got the original version from me, but use them for whatever you want. And this slide is another little reminder for you to download. It's a pretty big file for Oscar's talk, which is coming up next for the demo. So take a picture, get it downloaded. And you'll see at the footer of my slides, all of the rest of the ones, there's a little link to my slides and then also a link to some collaborative notes. And you're welcome to click on those links now, but I'm going to explain those as we get to a certain sort of about halfway through. Just if anyone's interested, this maybe it's going to be a little bit bad once this goes up public. There's a spectacular image of Thomas Paus on Getty Images. You've got to pay $600 to use it. So I picked this one instead, which is a great image. But there's a really good one with lots of brains in the background. So if you Google that, you'll enjoy it. But he literally wrote the book on population neuroscience. And population neuroscience is talking about the power that you can get when you move away from there's two aspects to it. One is the power that you can get when you move away from just looking at the amount of data that one individual or even one research group can collect, and you start to actually conduct epidemiology sort of sized samples. And a lot of that is what Cameron's already talked about. But the other, and you can start to generalize to a population, you can start to really affect either clinical practice, or you can affect policy decisions. You can look at intercultural differences. There's lots of these sort of analyses that one individual data set, that one individual lab can collect is limited on. But the second aspect of population neuroscience is that you bring together with the brain imaging information about the person, and that is as broad as where they were born, what year they were born, what they ate that morning, what their auditory processing is like, what their cognitive abilities are like, what their family history of mental illness is, and also aspects potentially of their genetics. And when you bring all of that together, then you can really start to look and answer particularly interesting questions. So in this case, this is a slide from Professor Paus's paper. The investigations that he was looking at were pulling together not just brain imaging, but also knowledge about the genetic information from both parents and the children, the gene expression that's there, the social interactions that they've had, their life habits, what their sort of substance use are, everything else that's there. And I hope that that is sufficient to sort of convince you that this is worth doing, that the questions that you can answer with a population neuroscience approach is really powerful. So now I'm going to be all like Debbie Downer on stuff and talk about the fact that you can't really anonymize that data. And the the machine learning, the computer science world has attempted to anonymize data. And as we move into a more connected world and as more and more data becomes publicly accessible, actually it's extremely easy to identify people. And I just want to pull out, so this is a paper that talks about the broken promises of privacy. And I just want to read out one sentence from it. These scientists have demonstrated that they can often re-identify or de-anonymize individuals hidden in anonymized data with astonishing ease. By understanding this research, we realize we've made a mistake, labored beneath a fundamental misunderstanding which has assured us much less privacy than we have assumed. And as a specific example, Netflix had a competition for anyone. I think it was $1 million that you could win if you did the best job at improving their algorithm. And they were sued by a class action lawsuit for every individual whose data was anonymously shared for that competition, because actually when you looked at what they were watching and you looked at things that they had rated in the anonymized Netflix data set, you could very easily link that up to reviews that people had written on, for example, IMDb, on public websites. And the reason that I have a picture of Brokeback Mountain on here is that this Brokeback Mountain is like specifically mentioned in the lawsuit because there was a closeted gay woman who was part of the lawsuit who said, "You are potentially outing me. I have these reviews up on these websites, but I also watch movies that sort of give away some of my personal interests." And she was not consulted. There was not consent for that. And there are places around the world, there are communities around the world where some of this personal information is damaging to the individual if it is more widely known. So it feels, when you come from science and you have very positive motivations of wanting to do good research, wanting to build up studies that pull together data so that we can answer better and more interesting questions, it feels really frustrating to then have to say, oh, but there are bad actors and there are people who don't think about these things carefully. And this brings me to the GDPR. Oh, yeah. This is a screen grab of my inbox. I did a search of privacy policy GDPR. You probably can't read it, but all of those dates on the right-hand side are the 25th of May. That's when the EU-wide legislation came in to really, really ramp up the rights that an individual has over their data and the responsibilities that data holders, mostly the tech industry, but also some scientists, have on sort of taking care of that data. So this is I was just Googling for an image about GDPR, and I thought this was kind of a cool cartoon. I actually don't have anything to do with this project management software, and I'm not advertising it. But I do like the fact that the GDPR gives many more rights to the individual. You have a right to know about the information that is held about you. You have a right to rectify it. So if it's information that is not correct, you have a right to ask that company, Facebook, Google, Twitter, everyone else, to update that information if you want to. You also have the right to be forgotten. So there has to be a process whereby you give both explicit consent to join, and it has to be as easy to be removed from a database as it was to join. And I work at the UK's National Institute for Data Science. We've had so many talks and conversations about the GDPR. I can't even sort of begin to tell you about it. But there was one presentation that I went to that I really loved. And a key point there was that if these tech companies, and if we as researchers build databases that allow the privacy and allow the rights of all of the participants to be compliant with the GDPR, not only are we doing the right thing in terms of protecting people's privacy and access to their information, but also we will do better science. If we collect our data in a really clean way, we will be able to mine it and we will pull better information from it. So GDPR, man, it's a pain in the bum. It's basically because a bunch of really big tech companies have abused the information that has been given. To some extent, the scientists sort of and the research data, there is an exemption for research data, but also this is why we can't have nice things. People have abused it. So this is the world we live in. It's 2018. We have to understand that it's part of it. If any aspect of the data might be used by anyone in the EU. So if any of me is going to touch your data at any point, you have to be compliant with the GDPR. And this brings me to a slightly, I struggle kind of internally with this statement of fair but not open. Because I had a fellowship for open science. I am a big advocate for open science. However, FAIR stands for findable, accessible, interoperable, and reusable. And you can find information, you can access information. That information could be interoperable or not, meaning that it can be used by different applications or by different people with ease. And it could be reusable depending on the license or not. And none of those requirements actually need the data to be open. It's much easier if you can click a little button and just have it download straight away. Oh my goodness, definitely. But if we are going to take our responsibilities to the individual seriously, there are some pieces of information that we have to make transparently accessible but not open. So this is like the main sort of point of my talk now is data transfer agreements. And I already sort of alluded at the beginning that this was like the vibe that I mostly feel about data transfer agreements. I've given the first part of my talk all about like why they're really important and why we need to have them. But if anyone in the room has ever actually tried to do a data transfer agreement, it's usually outrageously difficult. And I think the reason that it's difficult, is because there's multiple stakeholders that come in when you think about the process of sharing data and the process of making your data publicly accessible, not necessarily open, maybe only accessible. Researchers have very different motivations on sharing their data. I think Cameron talked an awful lot about the various sort of motivations of doing good research, doing faster research, being able to ask questions that you wouldn't be able to working on your own. The Ethics Review Board, so I'm the chair of the Turing's Ethics Review Board, and it's a pretty interesting space to sort of review machine learning and deep learning algorithms on quote-unquote public data. They have to understand what you're trying to do and what the potential consequences of what you're trying to do could be, potentially thinking about both the benefits and the risks, some of the negative consequences. The university legal team, I think, take that even further. The university legal team are like, don't sue us, don't sue us, don't sue us. As a very sort of brief side note, your universities or your research institutions are always under attack. Cambridge Neuroscience, the website, has been hacked a couple of times and replaced with sort of ISIS flags and images. It's a very strange situation. Just to be clear, there's no data on that website. That is just a website with information. Everything is protected, but your IT team at your institution, even though it feels like they throw up a lot of barriers and make things very difficult, they do have this other aspect of their job, which is making sure that everything is secure all day, every day. And then there's the funders. And I think different funders will have different motivations, but I actually think that most funders really do want data to be shared. I think they shell out a lot of money to collect neuroimaging data, to collect all of this deep phenotyping, and it is deeply inefficient. And I think they really see that it's deeply inefficient for research groups in exactly the same institution, research groups in the same country, research groups around the world, to not be able to benefit from that work. Just as a little lighter note, I was on a bit of a GIF train yesterday when I was making these slides, and this is the only one that came up for stakeholder. I'm like super freaking into it, so I'm keeping it. I'm going to transition now into a slightly more active part of this talk, but I'm going to spend just a couple of minutes reiterating to you all something that you already know, that science is done by humans. And that means that these frustrations that, for example, I feel when it's difficult for me to get access to data, I think it's quite beneficial to think about how difficult it is logistically from the other side. So having guidelines, writing up the guidelines, making it easy for people to understand information is a lot of work. There's a lot of effort and a lot of time that has to go into communication beyond just the guidelines. Engaging all of those stakeholders, getting them all to sort of see the benefits of different angles and why accessing data is important, again, takes a lot of work, it takes a lot of emotional effort. There's going to have to be, in my experience, there's going to have to be some compromise along the way. And you have to manage some expectations. I may want to just download everything that Cameron advertised in his previous talk. I was like, that's amazing, I want it now. But I can't, for all the reasons that I've just said. And so the key word on this slide before we go into the collaborative document is empathy. So if you all go to this link, it's a Google Doc. Let me just flip out of my slides and I will pull it up for you. So it's a Google Doc. It should be publicly available for editing. I think you'll mostly all turn up as anonymous various animals up here when you join in. And I have set up a few spaces for you to help each other to share all of the experience that's in the room. So there's a section on phenotypic data sources. I'm going to give you a little tour of accessing information from the Healthy Brain Network, from ABCD, and also from UK Biobank. But there are all of these templates, sort of sections further down. And I would love for you in the room to share studies. I'm going to have like a 5-minute section where we all sort of sit and type quietly for a little bit at the end of the tour of these first 3. And I've also left some of these blank lines to ask you, as people in the room, as experts who have already gone through this process in various different ways, to put in links that you've found particularly useful, advice that you've found useful, some of your personal experiences, and then I'll get to these 2 questions about whether the data is fair and can a user provide feedback in a little bit. The personal experiences, please be considerate of the fact that A, this is a public document, and B, there are humans behind the processes that may have frustrated you. So personal experiences where you say, this was really great, this was really amazing, wonderful, please add those. That really helps people choose which of the data sets they're going to use. If you found something particularly frustrating, maybe take a moment and just think about how that could be perceived from the people who created the process. I still think it's really valuable to say, so for example, if accessing a data set takes 6 months to a year, that is a super valuable piece of information for a master's student that's only got 1 year to do their entire project. Add that in. If you have experience on that, add it into the document, but be cautious about maybe how you communicate that information. So you've got that link. Let me carry on with my little sort of tour. So you already heard an awful lot about the Healthy Brain Network, so I don't need to repeat the point of the study. If you go to this website, which is the Healthy Brain Network, this is the very public-facing, the participant-facing site, and you click on Science, it will take you to the Science page. And if you scroll down, you will see a little link. I know you can't really read this, but it's hopefully so that the slides are useful for you after you leave the room. A link to our scientific data portal. And when you go to the scientific data portal, now you're starting to see a whole bunch of information that's particularly useful for people who want to actually access the data and use it, rather than, for example, participants. And if you scroll down on that page, you'll see a link to, there's a few different links here. There's links to the neuroimaging data access. There's links to the phenotypic assessments, the MRI protocol, the EEG protocol. You can click on all of those and you'll get a lot of detail about the information as Cameron's already given you kind of an overview. But the data usage agreement is your key link. This takes you to this piece of information. This is the link at the bottom. And you need to complete the data use agreement. The data use agreement is a PDF. And what is particularly nice about this data use agreement is that it's already filled in. So what you have to do is just scroll on down. You need to have these 3 required documents. You can't see it's off the top of the screen. Appendix 1 is 7 of 9. So I have not screen grabbed the 7 pages of legal language. It's there. If you really feel deeply about reading it, you can. But the nice thing about this is that it's already completed for you. What I wanted to highlight about this is just an appendix, but I think it's a really nice responsibility to communicate to the user what good practices are for taking care of this information. So they are sort of, when you sign this data transfer agreement, you are taking on the responsibility of not trying to triangulate and identify someone, and also not leaking the data and not sharing it with people outside of this process. And I think it's very nice that there's a page that really takes you through some of the key steps of what good practice looks like for that. And I have to say, that's a good page, full stop, for any data set. You should check it out. And then on page 9 of 9, this is where you actually have to fill something in. So it's your first name, last name, your degree, your academic position, institution, department. These are all pretty fine. You need a research project, you need a title, and you can select which data is requested. There's another page in the PDF that explains what data you can get. And then they have written a standard scope of the work. You do not even need, this is what makes this, I think, a really lovely and very easy example of getting access to data. They have written a standard scope of work that says exploration of brain structure and function, including its phenotypic relationships, using a combination of morphometric fMRI, functional MRI, diffusion MRI, EEG, as available, as well as any accompanying medical, physical, laboratory, psychiatric, cognitive, and behavioral phenotyping measures. So that's everything. And that's what you're going to do. You're going to do that study. So you don't have to write the project proposal. What you need to do is, you as the principal investigator need to fill in your information. Again, you know that's pretty easy. The hard part, truly the hardest part, is this authorized institutional official. And this, for me personally, has been a huge barrier, because I have often got to these points in a data transfer agreement and been like, I don't even know what that means. What is an authorized official? Who is the person at Cambridge University that holds the magic pen that's allowed to sign this place? How do I find them? What am I supposed to do? Now, my personal journey on overcoming that frustration is that I have been sitting on a committee for 2 years. It's really fun, trying to also share data. And as a result of that committee being in place, I have met these key stakeholders at the university. And so I now know the right people. But what I am here to tell you is that a simple Google search also provides the information. So this I find like a sort of somewhat hilarious / frustrating aspect of doing a PhD, doing research in general, is that truly your Googling abilities, your ability to search for information is actually like the number one skill that improves over the course of that degree. And it has never even occurred to me that if I just typed those words and the University of Cambridge into Google, I would find the information. And I'm here to tell you that you do. So this link, this top link, I could do like I'm feeling lucky, takes me to the research operations office. And then on the right-hand side, it takes me to my contracts team. And I know that I'm employed by the School of Clinical Medicine, so I can click on that. Now, I haven't actually done a screen grab of the next page. The link is on here. You can use it. The reason that I haven't done that is that that page literally goes to like a whole list of names, email addresses, and phone numbers. And I thought that maybe that was a little inappropriate in a talk about data ethics to then expose everyone's email address and information. It's a public page, so you can easily find it. But I don't think many of you are here from the University of Cambridge. What I want you to feel empowered to do is that same Google search for your institution. And there literally is a whole team of people who are available to answer the question. They're not used to it to varying degrees. They're not used to receiving these questions, but they are there and it is their job, and they will know how to fill in these legal forms. So you then track that person down. I really encourage you to like just email with them back and forth, figure it out. And once you have that, you have your, can I do my mouse? No. 2A, you have the DUA certified and co-signed by the principal investigator and an authorized institutional official. You have the scope of work, which is already written for you. And then you put together a little CV and you send that off. And what's also nice about this process is that the review criteria, the procedure is right there, and the review criteria is right there, because that's another thing that often a lot of projects are somewhat obtuse about. Like, what does it mean to be accepted? What do you have to write? To what extent? So I've got this link in here again just to remind you that you can add in your personal experiences. They're really, really valuable. Another study is the ABCD study. The ABCD study is I thought this was going to have text for me to read, sorry. It's a huge prospective study that is collecting information from 10,000 9-year-olds and will across the United States, and will follow them for 10 years. So it's going to be this spectacular data set. And as part of the funding, they are mandated to release that data every year. So there is already data available for 4,500 9 and 10-year-olds. And you can go find out more about the study at this website. If you're a scientist, you can click on the scientists link. You can scroll a little bit further down, and that will take you to the data sharing page. You can also get information about the assessment protocols and what data is available. When you go to the data sharing page, you then get directed to the NIMH, the National Institute for Mental Health Research Data Archive. There's a lot of like clicking. I think one of my big things is just like have confidence in your clicking through the web skills here. Once you go here, you have to request access. You then have to create an account, and creating an account is pretty easy. It's, first name, last name, username. It's not too burdensome. You have to not be a robot, so be careful about that. And then, here we go. Once you have your account, then you can log in and go to this data permissions dashboard. And this is a screen grab of my data permissions dashboard. I have a data access agreement. I have not made it to Cambridge. I've been traveling an awful lot. I have not made it to Cambridge to fill this in. But let me just real quick pull over to here. Where's my mouse gone? Oh, here it is. Can you see this? No. Here we go. So this is the actual website. And what I want to highlight to you, here we go, is this is all of the information. When you go through trying to get access to the data, in this case, you have to give, you have to be employed. When you make your account, you have to link to a verified employer. So there has to be, you have to be affiliated at a research institution that follows the same sorts of ethical processes that is expected from the NIMH. Most universities, most research institutions will be on this list. It is a little bit difficult if you wanted to be an independent researcher, you wouldn't be able to get access, or it wouldn't be easy to get access. You'd have to get a special agreement. I had to give a research title. I wrote a little project description. Let me just see if I can easily drag that. It's pretty short, right? It's, 200 words. It's not super burdensome, but I did have to engage my brain and think about what research I wanted to do. What is very cool is that, and I'll go back to my slides now just to keep everything moving pretty quickly, is that sorry, no, I didn't take that screen grab, is that this regenerate data use certification agreement, when you go through the process, it fills this whole thing in for you. So you fill in a web form, it saves that data, and then it puts that information into your data use certification agreement. So again, you don't have to read through the whole legal form. You don't have to see where your information needs to fit in. That's done for you. And I think it's a really nice touch. The best thing though, which I just want to sort of shout out because I think it's really excellent, and I would love other groups to sort of implement this, is that, so this is the information. It says here, read the instructions, provide your research project description. And then it says, you'll see a list of signing officials. So the coolest thing as a little sort of feature about this is that I had to say what my organization was, and then it gave me a list of 6 different names. And I picked the one that was in the clinical school. I was like, that seems most appropriate. And so they literally gave me the contact details and the name of that specific person. So now, and this is the step that I have not done because I've been traveling too much, I have to go and take this form, this PDF form, I have to print it out, and then I have to get that specific woman to track her down. She needs to sign it. She will probably spend some time reading over the text, but I trust them. And then I will send that back off, and then I will get access to the data, to all of the data. The last example, is UK Biobank. UK Biobank is an incredible resource, as Cameron has already said. It's literally an order of magnitude larger than anything else that exists for brain imaging, but it's harder to get access. So UK Biobank is a national and international health resource with unparalleled research opportunities open to all bona fide health researchers. It is not just brain imaging data. There's lots and lots of different types of imaging and genetics and much broader health information that's available. If you go to the register, so if you click on the register and apply link, it takes you to this page. You go to the access management system, and it takes you, I skipped a few because I knew I was going to run out of time. You go to the access management system, you have to make an account, you fill in your account, you go back and forth. It actually takes about, I think, a week to 2 weeks to get your account. So a human verifies your account in the background. So there's a little delay, but it's not too long. And then you're able to put together an application. And this application is more burdensome. So you need a project title, you need a research question, does your project require biological samples? In this community, probably not. That would be if you were going to actually do some more experiments on like cells in dishes. Does your project require UK Biobank to recontact participants? It depends on what you want to do, but that's not really reusing public data. That's kind of doing another study on top of public data. So probably you'd answer no to both of those. You then have to write 300 words of the background and scientific rationale, a brief description of the methods that you're going to use, the type and size of the data set required, the expected value of the research, 6 keywords, that's not that burdensome, a lay summary of the project. Will the research project result in generation of new data? This is actually kind of a cool point, that if you're going to develop a method that's actually going to be really useful, they actually require you, which I think is a really good thing, that you give back some of those derived measures. So if you publish a paper and you say, like, I've got this new biomarker and it's really great at predicting someone's risk of schizophrenia, they want you to put that back into the biobank. So it's a mandate, but I think it's a really good mandate on that. And then you go into this like sort of fun and exciting shopping basket. You have to create you can't read it. It says create your application basket. And your application basket comes from the data showcase. So I just picked one example just to show you what this is like. This is all public. This is not behind any, so you don't have to log in for this. But if you browse, you can click on, some of these different folders, and you can go, actually, again, I didn't put in all of these different screenshots, but you go into the UK Biobank, you find some cognitive tests, you think maybe fluid intelligence seems kind of interesting. Oh, look, they have like 13 different fluid intelligence measures. I'm going to pick the fluid intelligence score. Seems like a pretty decent one. And it will show you how many people, so this has 190,000 participants, and this is the distribution of those values. So when you're putting together your application, you have to very explicitly state which values you want. And you have to justify those in that form. So although the form itself is quite short, it's only 200 words, 300 words. It's not a sort of 50-page grant application. Actually, there's a lot of thought that needs to go into getting access to the data. The other thing that I want to flag up for you is that your collaborators have to already have an account. So they have to go through the getting an account process that takes a week to 2 weeks. And you're only allowed to name them as collaborators if they are already in the system. So there's no process for adding in, these are the members of my team, or these are the people that I want to work in. They have to have individual accounts. There's actually, I feel like I'm slightly bashing UK Biobank by highlighting that this is challenging. I actually really don't want to. I think they have done a lot of thought, and they have done a lot of work, and it will be a really valuable resource. The information is all there if you sort of give yourself the time to really explore the links on their page. Their FAQs document is very nice. The last thing to really highlight, though, is that you have to pay to use the UK Biobank data. So that link takes you to this link, and this link allows you to look at costs. It costs £250, which is about, let's say, $300 US, to submit an application. So that's a big additional burden. And you need to then pay £1,500, so let's say like $1,800-ish plus VAT, which is about 20%, so it's a bunch more, to then actually get the access to the data. So this is something that you need to kind of have some sort of funding in place. We are not going to be able to do the collaborative writing. I can see a wrap it up, Kirstie, sign. But that will be a permanent link. Please go and fill it in. Please fill it in the break. Please complete it during the questions. I'm going to have, I think, 4 more slides where I'm going to get super opinionated about life. This is the next talk. This is Oscar's talk on perfect data doesn't exist. And he's going to talk about quality control of the MR data. I want to very, very strongly advocate to you that you quality control the phenotypic data that you get from any publicly available data set. And I am not super confident at the moment that each of these publicly available data sets are interoperable. They often use their own personal directory structures, their own individual ways of sharing the data. And Cameron already introduced the BIDS project. I'm a huge advocate of that. A project where you basically come up with like essentially naming your files and where to put them sounds on the surface extraordinarily boring. But the huge power that comes from having all of those different repositories that Cameron had on a slide at the beginning of his talk, all storing their data, not just the brain imaging data, but also all of the phenotypic data in a standard is massive, is really powerful. So in the future, I would love to see more interoperability considered by the people who own these data sets. And also, to really try and come up with bidirectional communication from the owners of the data set to the users. So at the moment, there's actually quite a lot of FAQs, and like the biobank one has a phone number in the top corner, and you can call them, and you can get help accessing. But I have not yet seen, and I would love to be shown to be wrong on this. I would love to see positive examples of data sets that explicitly ask the users to tell them when they find bugs, when they find sort of errors. When you do the quality control, how do you make that easier for the next person? So I've put this slide up. This is a GitHub image. And I think there's a lot of conversation about sharing code and working together so that you don't have to reinvent the wheel. But what if we also did that with data and with metadata? Going back to my multiple stakeholders and Buffy here. And I also want to just have my super strong opinion about the incentives in academia. So it is very, very difficult to convince people who have survived and thrived in an old-fashioned status quo system that giving other people their data is going to be a good thing for them. I think the paper that Cameron talked about right at the end of his talk is really valuable. I was a reviewer for it. I really liked it. I think it really sort of gives some evidence about the fact that you can do much better science if we change this system. But be aware of the fact that the system as it stands right now is currently set up to explicitly make it difficult for people to reuse your data. So I know of 2 projects, not ones that I've mentioned here, one of which reviews those applications and will reject any projects that sound similar to ones that the PIs want to do. And another one will not share any pre-processed data, will only share the rawest of the raw data, because that makes it really, really difficult to actually use it and go all the way through. So I'm going to finish with this slide that although I talked an awful lot about ethics and the rights of the individual and honoring all of the participants that give us access to their information, that really important information that allows us to do incredible science, it is unethical to not share your data. It is wrong. It slows discovery. It violates the desires of the participants who want to contribute to science. It perpetuates huge inequality around the world, but also within different institutes. Sorry, this is an opposite one. Spot the deliberate mistake. By sharing your data, you improve the quality. It limits the new techniques, and it costs more to the taxpayer. It's wrong, it's unethical, and these clear processes are really important. Time's up. Thank you. And here's the link if you have any questions. Sorry.